If you're trying to get your students to be able to simplify any fraction, try this. Here I have 10/12. I've drawn 10 and 12. I know they have one common factor, and I can find that common factor by subtracting. 12 minus 10 equals 2. That's the part right in here, actually. I know it's a common factor, so I can skip count 2, 4, 6, 8, 10, and 2, 4, 6, 8, 10, 12. So now I can divide out that common factor from the numerator and denominator and get 5, 6. But I can also make sense of why 5 and 6 make sense, because if the size is 2, now I've got 5 pieces of 2, and then in here is one more. So I've got 6 pieces of 2, so that's why it all makes sense. Now let's try a much more difficult fraction. So now with 72/90ths, if I do 90 minus 72, the difference is 18. That's what goes right in here. That could be, well, that is the greatest common factor. Now here's one with 2 odd numbers, and if I do 33 minus 21, I get 12. Now let's play around with that 12. So you can see here, I hit on 3 as being the common factor of 21 and 33, and I divided up into those pieces. I checked the math. Now over here with 6 and 2, you could figure out that 6 is 3 times 2, and 3 will eventually work. So the key here in using 3 is I subtracted to get 12, and then I saw if that difference is a factor of the numerator and denominator. Now 12 does not skip count to get 21, so I knew it wasn't going to work. So I kept factoring out 4 and 3. When I used 3, I could skip count by 3 to get 21. So you see if the difference is a factor of numerator and denominator, and if not, you factor the difference. And one of those factors has to work. And if they don't, you got to refactor the other difference or the difference and start over again. So it's pretty complex, but also not. And it does allow you to do any large fraction, even something like 72 over 90. Difference is 18, and that actually is the common factor, the greatest common factor of 72 and 90. Thanks.